Hi everyone, I am Dr. GOPI KRISHNAN, Assistant Professor, Department of Mechanical Engineering, Dr. NGP IT. Today we are going to see a problem related to the perspective projection, and this is going to be the problem. Let us start with the problem. Draw the perspective view of a square pyramid of base 40 mm side and axis at 80 mm resting with its base on the HP. Here we have the square pyramid, and this can be taken as a square pyramid, and the base of the pyramid is a square and it has a height of 80 millimeter. It rests with its base on horizontal plane, and in the first quadrant it lies with its base on the horizontal plane this way. Right. So this can be called as the apex, and this is called as the base, which is a square. Right. And the height of the solid is 80 mm, and the base side is taken as 40 mm square, and it is resting on the horizontal plane this way. Right. And the nearest edge of the base is parallel to and 15 mm behind the picture plane. The station point is situated at a distance of 30 mm in front of the picture plane, 90 mm above the ground plane, and 20 mm to the right of the apex of the solid. Right. And before getting into the problem, we have to know something about the various planes used in the perspective projection. And we have already seen that this is going to be the solid, which rests with its base on the horizontal plane this way, and I am the observer, and I am going to see the object in this way, and the plane that rests between the object and the observer can be called as the picture plane. It lies this way. This can be called as the picture plane, right? And from the given data, the picture plane lies at a distance of 15 mm, that is picture plane lies at a distance of 30 mm, that is in front of 15 behind the picture plane. The solid is resting with the distance of 15 mm behind the picture plane this way, so the distance is 15 mm. And the observer is standing at a distance of 30 mm in front of the picture plane, right? And this can be called as the picture plane, and this plane can be called as the horizontal plane, and the plane on which the object lies can be called as the ground plane, and this is going to be a plane called the central plane. So we have to know about the four planes in perspective projection, and this is the perspective plane, this is the horizontal plane, this is the ground plane, and this is what we call as a central plane, right? And every detail is given in the problem, and the station point lies at a distance of 20 mm to the right of the apex of the solid, and this is going to be the apex of the solid, and the station point from where the observer lies, he is lying at a distance of 20 mm to the apex of the solid. So the distance of 20 mm from the apex, the observer lies here and sees the object here. So we are going to make a perspective projection or the perspective view for the given solid, right? So first we have to draw the top view for the given perspective projection problem. So the first step, we have to make the top view, then we have to make the front view, right? Since it is a third angle projection, we must start with drawing the top view first, then we have to go to the front view, right? So the data given about the orientation of the solid is nothing but the solid, the nearest edge of the base is parallel to the picture plane. It is given as this is going to be the solid. In the top view it resembles in this manner, it takes a new orientation this manner, and the nearest edge of the solid lies at a distance of 15 mm behind the picture plane. So you have to make a solid that is base square this way, and we have to make a distance of 15 mm to represent the picture plane, right? So we have to name the base corners and apex of the given solid. So I take it as A, B, C, D and O for the top view. Top view is over now, right? And the distance between the nearest edge of the base and the picture plane can be taken as 15 mm. It is already drawn. Then the station plane we have to locate and look at the data. The station plane lies at a distance of 30 mm in front of the picture plane. So we have to go and make a parallel line, horizontal line, and this can be taken as station plane SP, and it must be taken at a distance of 30 mm from the picture plane in front of the picture plane, right? And the station point lies at a distance of 20 mm to the right of the apex of the solid. You have to go and mark the apex of the solid. This is going to be the central plane, and we have to make a point here, intersection here, and to the right of the apex of the solid we have to take it 20 mm. So 20 mm may be here. We have to take a distance of 20 mm and the station point can be taken as a yes. Right. Now the top view is over. Then we have to go and draw the front view and then we have to make the perspective view of the given solid. Right. And after completing the top view we have to go and represent another parallel line to indicate the horizon plane in the front view. Right. As you know, the horizon plane is nothing but it is a parallel plane which is parallel to the ground plane, and this is going to be the solid, and the horizon plane is nothing but the plane that lies at the height of the eyesight of the observer this way. Right. So after making the horizon plane we have to go and find the distance between the horizon plane and the ground plane, and from the data given in the problem the distance between the horizon plane and the ground plane is 90 mm, right? So at a distance of 90 mm, we have to make a parallel line to represent the ground plane this way. This can be taken as GP, right? GP is ground plane, right? Then we have to go and mark the height of the given solid, which is nothing but 80 mm. So 80 mm can be taken as this point, and you have to make another parallel line. And this can be taken as a distance of 80 mm to represent the height of the given solid. Right. This height is 80 mm. Right. And then we have to project all the base corners and apex to the other side to get the front view. Right. So we have to project all the base corners and we have to project the apex. Right. And we have to locate the corners and their names in the front view, right? So it has to be named as A dash, D dash is invisible, B dash is here, C dash is invisible, and similarly this can be taken as a O dash, right? Then again, we in the front, in the top view, we have to go and see the object from the station point. So I have to view the base corners and apex from the station point. For this, I have to make visual rays connecting the station point to the base corners and apex this way, right? And this is going to be the visual ray used for viewing the corner C. Then this is going to be another visual ray to view the apex O, right? And this is going to be the another visual ray facing corner D. And this is going to be another visual ray used for viewing the corner A this way, right? Now we have to go and locate the piercing points of various visual rays in the top view this way. These are the different piercing points located in the picture plate, right? And these piercing points must be projected to meet the visual rays of the front view to get the perspective view, right? So for that we have to project the S to the other side to denote it as a S dash in the front view, right? From the S dash we have to locate, we have to see the corners through visual rays, and this is going to be the visual ray towards A and D. This is going to be another visual ray towards B and C, right? Now we have to go and check the intersection between the piercing points in the top view and the visual ray in the front view, right? So how do we get the perspective view for the given solid? We have already made the top view and front view for the given object, and to get the perspective projection we have to go for intersection, and the intersection between the piercing points in the top view and the visual rays in the front view must be noted down, right? And I have to go and take the first point here, and this is my first point A in the top view, and this is the visual ray corresponding to the corner A, and this is going to the piercing point of A, right? And this point has to be marked in the other view. It has to intersect with the visual ray corresponding to A, right? And when you make a projection of this piercing point towards the other side, I will be getting a point here. That is, this is going to be the intersection between the piercing point of A and the visual ray towards A in the front view, right? Similarly, I have to go for the piercing point of B, which is here, and this piercing point of B must be projected towards the visual ray in the other view. So I will be getting the intersection here. this can be taken as capital A, this point has to be taken as a capital B for the perspective view, right? Then again I have to repeat the same procedure. This is the point C and this is the visual ray with respect to C and this is the piercing point with respect to C. It has to be projected to the other side till it meets the visual ray in the front view, right? So this is going to be the point, the intersection we have done. It can be named as capital C, and similarly this is the piercing point at D. When it is projected towards the other side, I will be getting the intersection here marked as capital D, right? Then I have to see the apex of the given solid. This is going to be the visual ray of apex, and it has to be intersected with the piercing point of O is here and the piercing point of O lies here. This is going to be the point called the capital O, right? Now we are going to complete the problem. We have to connect the base corners, that is A and B, by a solid line, continuous line, right? And when the observer is standing here and he is viewing the object in this manner, he can be able to see the corners AO, OB, OC and the base corners, base edges ABC, right? So we have to mark AO in a straight line, continuous thick line, and this can be taken as AO. AO has to be marked in straight lines, continuous lines, and similarly OB and OC needs to be drawn in a continuous line, thick line, right? Similarly CB, right? So look at the picture here. That is A, B, C are visible, and similarly AO, BO and CO are visible, right? And the farthest point from the observer is D, and the edges connected to D are always invisible, right? So what are the edges connected to D? So D is connected to O and D is connected to C, D is connected to A. All must be indicated by means of the dotted lines, right? So D is here. D must be connected to C by means of the dotted line, and similarly D must be connected with A by means of a dotted line, and again DO must be connected by means of the dotted line. Right. So this view can be called as the perspective view of the given solid. So this can be written as perspective projection of the given solid, and the problem is over. Thank you.